Okay, so we'll talk about threat modeling, and what we'll do is we will go through a threat modeling exercise in class. And so at a high level, these are the steps. You essentially have a protocol, right, on chain, and what you need to do is start decomposing the protocol. Then once you have the protocol decomposed, you identify and rank the risks. And then once you have that ranked list, you can talk about mitigations. And as I mentioned last time, if some risk can't be necessarily mitigated, that would be a great opportunity for monitoring. Okay, so the protocol that we will threat model is essentially a DeFi lending protocol called Spook. It's deployed on Ethereum mainnet, and it allows for over-collateralized lending of digital assets. So recall, you can basically deposit, let's say, ETH into this lending protocol, and then you borrow USDC. And since there is no credit score, you can only do that through over-collateralization. So you, for instance, deposit $150,000 worth of ETH into the protocol, and that allows you to borrow 100,000 USDC. So that's kind of the protocol on how it works. So Andrew, what we'll do today is we'll do a threat modeling exercise on a protocol that I'm describing, and we'll do that essentially in class. So there's not going to be a lot of slides. So the protocol is a over-collateralized lending protocol. And so a borrower can borrow digital asset B by depositing asset C into the lending protocol, where the value of asset C needs to be at least 150%. Of course, the risk there is if the price, so if you deposit ETH and you get USDC and the price of ETH drops, right, from, let's say, $1,500 to $1,000, then you essentially start getting into the area where your collateral gets liquidated to cover essentially for the asset that you borrowed. So when you are, so why would you do this? I mentioned this primarily for tax purposes because borrowing is not a taxable event. It's a decentralized protocol where essentially all the actors have incentives to participate. So obviously there's the borrowers that go to the lending protocol to borrow digital assets. And what they have to do is they have to pay interest when they borrow assets, right? So in the case of the ETH and USDC, when they then, let's say, want to pay back their USDC, they will have to pay interest in order to unlock their collateral. When the value of the collateral dips below a threshold, let's say 120% of the value of the borrowed asset B, then the protocol automatically liquidates asset C using a decentralized exchange. Then, so that's borrowers. Then there's also liquidity providers, because in order to borrow an asset, the asset needs to be in the protocol. And so liquidity providers are able to deposit their asset B into the lending protocol, and they then essentially earn interests on that deposit. So they earn 50% of 5% of annual yield. The remaining 50% interest is deposited into the protocol's treasury. So the protocol can continue to develop and kind of add features. Spook also has a ERC20 governance token, and that token allows token holders to change the parameters of the protocol through on-chain governance. So for instance, I said that the collateral percentage in the example here is 150%. And so the community could decide, well, we want to change it to 200%. And that then is essentially driven through the Spook token. On-chain governance proposals are time locked for 7 days after a proposal has been accepted by the community, and that's kind of a safety mechanism. So people can't just say, hey, I want the collateral to be, let's say, 90%, which means it's essentially under collateralized, and then kind of drain all the assets from the protocol. So I think that the way that works is then asset B gets asset C gets liquidated, right? So the collateral, and then asset C is swapped to asset B. So the people that provided.
So the liquidity provider will receive their asset B.
That's right. Basically, whatever they deposited, and what the protocol will do is when liquidation happens, it will actually exchange it. And just on a side note, when you see, large price movements in the crypto industry, often that gets exaggerated by leverage, but also exaggerated by these sort of protocols, because let's assume ETH goes down, right? The collateral, the price of the collateral goes down.
Like one automated system triggers another automated system triggers another one.
Exactly, and so then it would essentially, price of ETH goes down, then liquidation happens, ETH gets sold, essentially, the price goes further down. And so that's what you see a lot on kind of the large wicks that you see in price charts. So there are 4 users of the protocol. So there's the borrowers, the lenders, the Spook token holders, and then, of course, the Spook protocol developers. All interactions with the protocols happen through direct interactions with the smart contract, and this is just, this is not realistic, but for the purpose of this example, we're just focused on threat modeling. We'll just kind of ignore the DApp aspect, or supporting systems like on-chain governance systems. Further steps focus on the borrower use cases of deposit collateral and withdraw assets, and repay and withdraw collateral. So the remaining aspects are omitted, and that's going to be essentially your assignment. So what we'll do now is essentially try to model the aspect of deposit collateral, withdraw assets, and repay and withdraw collateral. Does that make sense? Any questions around the protocol itself on how it works? Okay, so this is the document. So it just kind of explains the general way you can do risk modeling, and there's a link to the OWASP threat modeling process. Excuse me. Okay, so first we need to decompose the protocol. And this is really about getting comprehensive understanding of the protocol and how it interacts with external entities like users, libraries, other protocols, what assets the attacker may be interested in, special roles assigned to the application. So let's focus on that first. So here is just the description that I copy pasted into the PowerPoint deck. And so first, let's look at external dependencies. So these are other contracts or libraries the protocol relies on. They can be configured and deployed during the protocol deployment or updated after deployment through special roles by the protocol's development team. It is good to note when these components are selected and whether they implement the proxy pattern, as immutability is a rare pattern implemented on chain. Oracles are a special type of external dependencies, as they often relay information such as price data from a set of external data providers. So when you create essentially the list of external dependencies, you should document an ID. That's going to be just for later for referencing, a description, information on whether the dependency is updatable, who owns it, and then protocol deployment steps. So when is the external dependency set? So let's think about external dependencies.
Consider mainnet to be external to the protocol.
Mainnet, no, I'm more focusing on the application layer, although let's think about that. I mean, I think it's a good point, because so if you think about the protocol may rely on transactions for it to function properly, and if there is, let's say, a set of validators that filter your transaction, there may be some delays that are introduced. Okay, so basically here we would say validators. And
Yeah, I think validator. Yeah, I think if you're like, there's a hard fork again, what happens? The validator.
so it's updatable to a hard fork, right? It's the owner is the ETH community, and the deployment step is really permissionless. Anybody can be a validator. Think about the application itself that is built. Okay. I think it's not really updatable. Then I think it all applies to the third. Yeah, oh, I think that's an excellent point. Yeah, no, that's a good approach. Yes. I'm just gonna say the Oracle is not updatable. And I'm kind of protocol developers. Yeah, I think there are certainly entities, but they're of course not necessarily a software component.
Which can be external.
That's right. Yeah, you can kind of treat me as essentially developer of the protocol, so I can answer questions. So yes, we do use a library to calculate the interest. Yeah. Just that. Because also it's the compiler changes over time, so you could have the you develop your smart contract, deploy that, it's a proxy pattern, and now you update and then your compiler changes. I don't know who creates the compiler. Yes.
I see the external thing, the backing contract, the external thing.
I mean, I would say that that is part of the protocol. So not necessarily the external dependency. Anything else?
For information provided, that's what I get to.
Oh, when the liquidation happens? Yeah. Holding it directly. All right, I have one more, which is essentially the protocol. So kind of the parameters of that encode things like the interest rate, the minimum liquidity, and the reason why I'm kind of calling it out as a external dependency is because these token holders control that through governance. So it's essentially initially at computation, and then again through on-chain governance. And just so you understand how that works. So basically, somebody in this book community will basically create a contract that implements a certain interface. And then there is a governor, which is essentially an on-chain governance contract that you can configure to hook up to your tokens. And what then happens, and kind of configure certain parameters like the lock period, minimum voting threshold, and then that contract gets deployed, let's say by me. And then I post on the forum of the community saying, hey, this is my proposal. Here's what it would change on the protocol and why so. and then invite all the Spook token holders to vote on it. And so they vote on it on chain, say yes or no. And then if the proposal is accepted, then that contract gets automatically executed to configure the new parameters of the protocol. So it's a pretty neat mechanism, but it has also been used.
Was used in the attack where they like defaced the name, the token.
No, they just got access to the private key. But it has been used in attacks where, think of this particular example, where if I basically submit a governance proposal that says the collateral has to be 90% or 50% or even lower, right? Then suddenly I can basically deposit small amounts into the protocol and borrow large amounts, essentially draining the protocol of assets. And so there was one attack that I remember, I think it was Beanstalk protocol, where somebody pushed a malicious governance proposal and then drained all the assets. And the other thing that was kind of neat is they essentially put out the proposal contract, and they used a flash loan to borrow a whole bunch of governance tokens. They voted, and then they gave the tokens back.
Oh, so they did a flash loan just to vote. So
That's right.
they basically were able to get a majority for a fraction for the interest.
That's
of the
right.
flash.
That's right.
Like the governance contract, like should depend on the number of voters, not like the percentage.
Yeah, I took even there, right? It's like I could just transfer tokens to as many token holders that I kind of essentially Sybil attack, right? And then kind of do it that way. It certainly would increase my cost and certainly is a little bit more painful to kind of manage all of that, but not necessarily a mitigation. Now, Spook mitigates that through a 7-day, what was it called? Time lock, right? So after the contract is accepted, it exists for 7 days before it gets executed.
Is there anything that, like, once it's accepted, is there anything in the protocol that allows for something to be rejected during that time lock period?
Oh, yes, there is a multi-sig that the Spook developers control. But not everybody has that, but this protocol will have that.
So Spook developers definitely count as a through that multi-sig.
Mm-hmm. Okay, so how these components are managed is an important aspect to pay attention to. They're governed by a DAO. Do changes impact the Spook protocol? Go through a time lock, essentially giving the protocol a heads up of upcoming changes. So that's going to be the case here. So next, let's talk about, or any more comments on kind of the external dependencies? Okay, so then let's go to entry points. So entry points define the interfaces through which potential attackers can interact with the protocol or supply it with data. So in order for a potential attacker to attack the protocol, entry points must exist. In case of an on-chain protocol, this primarily happens through on-chain transaction, or if a protocol is used, an oracle is used, an oracle needs to obtain data from somewhere. And so there's, of course, an opportunity to manipulate the data that the oracle relies on, which may be off-chain. So similarly here, we want to have a ID, name, description, and then a trust level. And the trust level is essentially the level of access required at the entry point. These then later will be cross-referenced. with the trust levels that are defined later. So what is essentially an input to the
Positive, withdraw, okay. Positive, withdraw.
Okay. So there's the, it's like, so deposit, I'm sorry.
That's what it's.
Yep. And then essentially there's the repay, right? So let's say, hang on, deposit and borrow, right? That's
Yeah,
the
yeah,
one.
deposit and withdraw, and then there's repay.
Yeah, okay, that's right. A deposit and borrow, trust level,
Basically, basic signature.
okay. Can any,
Transaction signature.
yes? But anybody could do that, right? So it's really permissionless. Okay, and then repay and withdraw.
Calls up to pay my bill, isn't that okay?
Yeah,
That's not if they're withdrawing. So this should be heated by the signature. Like it should be tied to the depositor's account.
that's right. So essentially the borrower, right?
Yeah.
Parameter, yep, the parameter complements. Right.
Off chain, right? Like management of the org was chain.
That's right.
That's like an external.
Mhm.
basically, like you could have the asset. Control numbers.
Although, you know, now that I'm kind of looking through the list here, like, I wonder whether this should be more in the assets category. But we're brainstorming. So entry points, are there any other entry points that you can think of? I think it's a good list.
Contract. Modified way of frameworks. You execute transactions against the contract. You attack the things that depend on the contract.
Attacker can theoretically attack the target book, like gain access to the bus.
Basically like a 51% too, is what you're saying.
Yeah.
No risk, but it's an entrance. The 51% attack is like, it's an entrance, it's everything, like this. Posture and the
Yeah.
I think if you go to 51, you would end up going through one zero. Like, if you wanted to take over a token contract, you would take over.
So if you take over the chain, what are you thinking about? Like, what would happen? Well, a 51% attack does not allow you to do that, right? You still need to sign transactions, and the transactions need to be valid, right?
Yeah, but the validity for the transaction depends on the validators. So if attacker gains 51% and any transactions that is valid to them can some person can be passed.
You're more talking, I think, about a hard fork, right? Where basically certain rules are disabled, but a transaction itself, even if you control 51%, I could not create, like if I control 50% of the Ethereum network, I could not create a transaction that impersonates me, right? Because the transaction still needs to be signed with my private key. Now you could hard fork and change the rules. And with the 51%, I suppose you could do that, but then you have two networks, right? Like you cannot convince the 49% of the validators to accept that block because the transactions are invalid.
Eventually, 51%, 49% will follow 50%.
They don't. Because they would have to update their code in order to change the rules of the protocol.
So you'd have to be willing to pay the cost of being 50% forever.
Well, even in that case, right? So basically,
You still can't mint transactions for other private keys.
yeah, what you could do is double spend, right? Because now there is potentially a fork. So I can always go back. So then next is the assets. So the protocol must have something that the attacker is interested in. These are items or areas of interest are defined as assets. The blockchain assets of interest are usually tokens. However, with exceedingly cross dependencies, even information like price data could be of interest to an attacker to exploit other protocols. So for instance, in this particular case, if I'm able to exploit let's assume this protocol has massive amounts of token. If I'm able to exploit it such that all the tokens gets liquidated on the decentralized exchange, that could have a significant impact on price. That then would allow me maybe to do something else, right? Even an attack that does not retrieve assets, like a denial of service attack, could lead to reputation impacts that could potentially impact the price of the associated token of the protocol. So the ransomware attack that I mentioned, where the token was defaced, right? Like if I'm able to, let's say, denial of service this particular protocol for a week, and they're holding billions of dollars, I think that will certainly impact the price of the spook token. Possible. So think about the scenario of a borrower deposits, borrows, liquidity provider deposits as well. So kind of in that context.
Just within the so don't worry about contract.
A list of here are the positions of the borrowers, right? And here are the positions of the liquidity providers.
Yeah.
And so I think those are definitely assets. So right, so any borrower's collateral, then C, right? So in order to borrow against asset C, for the liquidity providers, then and there is also the liquidity provider. Yield on asset, right? So interest that they earn. And then what happens with the other half of it? Yeah, no, I think that's a good point. That the time lock itself. Yeah, and now now also as you kind of mentioning these aspects, It seems like they're more stepping stones. Right?
Yeah, that's fair. They're not the thing I'm protecting.
Like even the time lock, like,
There's an argument for death there.
okay.
Don't protect any of the things that are protected.
Okay, trust levels. So in terms of the borrower's collateral, it is the who can act on the collateral.
We're not actually the system of record.
Who interacts with the collateral itself. So the
I think that like the
All the borrowers seem to control.
protocol. But
yeah, and in what scenario? That's right. So it's the liquidator role that is defined on the contract, which I haven't talked about. So then what about liquidity provider's asset fee that they deposited? So we have the borrower up there, and then of course here it's they get and that also applies to them. I suppose the token contract again. Duki was saying.
thinking like a full contract.
Well, is there functionality in the Spook protocol contract that would transfer the liquidity assets away?
There is the assets fee. So when,
That's right.
when the borrower borrows the asset, so the protocol will take the asset fee and transfer it to the borrower.
So that applies to these assets. So here, let's say, I don't know, the loan role. Let's put it that way, right? Or the lender role. Let's put it that way. Lender role. Does that also apply to the yield? You think so?
Always 10%.
Yeah, I think it could go both ways, right? A yield could be, as you earn interest, it could be, how you call it, where it's like aggregated, like cumulative, like where like the protocol could be defined where the yield goes directly back into the liquidity pool. And then the compounding, that was the word I was looking for, compounding interest. Or it could say, it's going to be separate.
About 10%.
Yeah, and so it's going to be separate in my protocol.
There's another asset, which is the liquidity token.
Yes, that's, liquidity token. We will not have liquidity tokens. Usually, yeah, you're right. Usually it's like an NFT that you get that is representative of your position. But yeah, for mine, it's gonna be tracking based on address. But we get the governance token. And so here the trust level is really, I suppose. And then the treasury really is controlled by, again? Could be. You could have a multi-sig that is essentially the developers that control it, or you could say the treasury is controlled by the community through the governance mechanism. So do that. We are a very decentralized protocol. And then the time lock, because it is a parameter that is defined through the governance mechanism. Okay. Anything else in terms of assets? We defined already a whole bunch above. Now, usually you would kind of cross-reference so the names are consistent. I'll just kind of skip that for now for speed purposes. But we essentially have deployer role, which is essentially the multi-sig by the and update. And we also had the spook token holders. Right. Which is really a, well, that is actually a whole bunch. It's COA. Any of those types of holder. We got the bar. Again, could be any other liquidity provider. We had a few rules. We had a treasury. Well, actually, no, we didn't have a treasury role because I said it's based on the community. There's a DEX smart contract. So the Oracle is a little special. It's not chain link with a separate Oracle network, but rather this protocol just gets the price information from a DEX, where it looks at the ratio of the both tokens and is able from that to calculate the price, as I explained, like I think last week on how that works. We got the which is library phone. This is fact. Any other roles that you can think of that we may have mentioned above? Oh, the liquidator role. Oh. And those are both. Well, actually, no. These are the contract, right? Don't kick this off manually. It's in the code. Any other roles you can think of? break, be back here 7:10. And then what we'll do is we'll create the data flow diagram that essentially visualizes all the components that we just identified. And then we will start identifying risks, listing those risks, and then we'll talk briefly about mitigations. And I think we should be able to do that in the rest of the time. And so maybe my promise of letting you out early identified essentially the entry points, the assets, the entities.
I think that I just like up with some kind of entry point.
Okay.
Yeah. Yeah. The entry point.
Which one? The DApps?
Yeah.
Yeah, that is true, but for the purpose of this exercise, I explicitly said DApps are excluded. You'll only interact with this through Web3 JS or Pi.
Otherwise, you have to do a full web
That's right.
model.
Didn't want to.
The Web3 thread.
Didn't want to do that. So then essentially you create a data flow diagram that's essentially kind of a visual representation of how the protocol processes data. And it kind of shows how data flows logically through the protocol end to end. And then they allow the identification of affected components through critical points. So for instance, data entering or leaving the system, storage of data, the flow of control through these components. And so the data flow diagram really focuses on how data moves through the application and what happens as the data moves. They are hierarchical in structure. So you can kind of go at a super high level and kind of then look at specific subcomponents in more detail. What we'll focus on now is really just kind of the high level of the two primary flows of depositing collateral and withdrawing assets, and then repaying your collateral and repaying the asset and withdrawing your collateral. And so there's a few aspects here, the kind of symbols that represents various aspects of the protocol. Like there's the external entity, which is a box. Circle is a process. Data store is this weird kind of two bars. Then data flow is essentially arrows. And then the dotted line here is a privilege boundary.
Things can exist on the boundary. Probably in most cases, you have data flows.
That's right. And so the software that I was using is the OWASP Threat Dragon. And I'm sure Microsoft has a visualization component.
It's not.
All right. Yeah, I mean, this also does not have templates for Web3. We'll have to.
But those are much simpler than like nothing in the Microsoft Web Model tool. Actually simple.
All right, well, let's see how simple this one is. So, okay, so basically, think of, okay, what we should probably start doing is identifying first the external entities. So what external entities did we identify? So we had essentially the borrower. What? Yes. What else? again, like as we kind of go back here, we may cut this list a little bit short. That's right.
Probably does matter.
Yep, Oracle. So let's focus on. Well, I'm okay. Yeah. So I think we got kind of these three actors or external entities, and we can always add a more, but maybe go to process model. And so the high level process is really deposit and withdrawal, right? So basically what happens on the way back after so this is essentially then asset, so X and B, right? So that's the asset that they're borrowing. And then we need another one. Oops.
X meaning like outbound.
No, the X was exactly. So then that is Y as C, right? So that's it. But essentially they send Y asset collateral and then they get asset B back. And so then the question is, where does the asset C come from? Right. So here essentially we have the liquidity pool at B. That's right. And so then we have data flow. Oops. So that is asset B, right? Okay. So then in terms of where does asset C go? Right, because now we're the borrower deposits Y asset C. That also needs to be stored somewhere, right?
In the treasury, doesn't it? Just the one that's 50-50 between the treasury.
No, I think it is like a unauthorized like pools.
That's right. I think it's the asset C collateralization pool. That's where then that comes in. Oops. Okay, so that's kind of where the tokens come from and where they flow to, right? So we deposit Y asset C, withdraw X asset B. Asset B comes from the liquidity pool, and asset C goes into the collateralization pool. Now, how is X and Y calculated? That's right. So
Well, why is provided?
yeah, that's a good point. Y is provided, and then basically X is calculated, right? So then basically we have a process that I would say basically calculates the sure. And so the way it can calculate X, so basically now X goes back into the function here, or the process here, right? So this is and what it needs is probably Y as input, right? There you go. Okay. So Y is input, calculates X, and how does it do that? By getting what? What does it need to calculate X price? That's right. Okay, so this is then essentially the price of B and C, right? What else does it need? So we have, so I go to the protocol and I deposit 100 ETH and I want to get USDC out. And I want to get the max USDC out. And so now it gets the information that, ETH costs $1,000 and I deposit 10 ETH.
Now it has to go with the authorized token transfer.
That's true. I mean, there's the approvals that will need to happen by the borrower to kind of act on those tokens, but I'm just I'm still kind of looking at how do you calculate X? How many USDCs can I borrow?
Oh, you have to apply the
expressal. So
collateralization rules for the contract.
Yeah, collateralization percentage threshold. Yep. So that comes from the parameter store of the protocol. Oops. Not many here. So let's call this the protocol parameter store. And what it gets from here is essentially the collateralization percentage. Okay, so we got all of that. And I think kind of as a last step, what we should think about is trust boundaries in terms of who controls what.
That's really like inside the smart contract itself.
Okay, so basically like that.
Yeah, and another one between deposit, withdraw, and borrower. Is the collateralization pool in the contract
Yes.
thing? The liquidity pool is with the liquidity providers. The state portion.
I mean, so what I would suggest actually is basically kind of put a trust boundary like this, where basically the borrower can interact with deposit and withdrawal, and it can interact with its collateralization pool, but it doesn't necessarily have access to the liquidity pool or the calculate the interest or collateral percentage. But I think what is certainly a trust boundary, is the oracle. So the oracle is a trust boundary. And then I think the protocol parameter is also trust boundary, because we talked about earlier that that is controlled by the community, right? That's right. So the liquidity providers would be kind of like, oh,
Like the old Microsoft orchard.
yes, like that. Okay. Perfect. That's it. Well, we're just gonna do one flow for deposit and withdrawal, but for the other flow, it would look very similar. So now we essentially have a visual representation. And so now what we're able to do is basically use prompts. And there's a variety of frameworks that you can use. There's the STRIDE framework, which is essentially stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. And so basically you look at your protocol like that and ask the question, okay, spoofing. Spoofing is a threat action aimed at acting as another user. This can be, for instance, accomplished by stealing a user's private key. And so you could ask the question, well, what if I am able to spoof the borrower, right? And so then what that would essentially allow to happen is somebody unauthorized could get access to the collateral. Or denial of service. What if you're able to control gas, where gas kind of shoots through the roof, transactions become very expensive. And now, let's say the Oracle is doesn't have kind of up-to-date price information. Other areas, so let me just go back to the document because there's a bunch of links. So here you kind of have the various prompts of the Stride framework.
Here. Could choose.
You can choose. The other one is the DeFi threat matrix. It basically contains a whole bunch of attacks that could happen in the general blockchain space. Now, I wouldn't expect that each of those kind of map into your protocol and threat model, but you can ask kind of the question around, okay, here's a particular attack technique, reentrancy. How does that apply to my protocol? Like, so for instance, we learned that reentrancy involves sending Ether to a contract, and you believe it's an EOA that then essentially does a default, a fallback function that then kind of invokes your contract again. That's right, exactly. So depending on how that is implemented, right? Like if it basically says ETH.send to bar, absolutely.
The approach that work usually is we identify the risks kind of in the abstract. So like without knowledge of the implementation in some ways. Hey, like reentrancy is a risk. It could happen here. Maybe it could happen like somehow like with the liquidity provider or something as well, let's say. And then I would go back and say, okay, well, what are my mitigations against that? It's like, well, I've done a code review and, you know, the 2 lines of code are in the right order.
That's right.
So it's like, okay, reentrancy check.
Exactly. And so now what we should, but yeah, so I was just kind of illustrating how the matrix works. So what we should do is now kind of go back to the document and go into the risks. So essentially we're trying to identify the threats that the flow that we just created could be exposed to. So we just talked about reentrancy. On the with every risk that we identify, we should identify the likelihood and the impact. Yes, and we'll do that on a score of actually I have it here. Oh, it's 1 to 3 for likelihood and 1 to 3 for impact, and then multiply, and that then essentially gives us a score from 9 to 1. So the 3 essentially being the highest likelihood and 3 being the highest impact. Now, in this particular case, reentrancy, what do you think is the impact? If this is essentially vulnerable to a reentrancy attack, 3. And that's right. And the reason why it's 3 is because in that particular scenario, it is not just the borrower's assets that are at risk, it's all the assets, right? Because basically the tracking is incorrect. And so I can then withdraw essentially the collateral from borrower B, C, D, etc. Likelihood, I would say, is fairly high. medium, I would say. And so now that gives us a score of 6. What are some of the other risks that you would identify based on kind of the diagram that we drew? It is called decentralized finance threat matrix. Say again? Yep, what's the risk? Okay. And how could you manipulate the price feed? Okay. And given what I told you about the type of oracle that we're using, what do you think the likelihood of this is?
Calculating it based off of the decentralized exchange.
The ratio. Yeah.
Okay. And then the impact?
All your assets, you're going to incorrectly liquidate. You might reject loans. You might approve loans that you shouldn't approve, but
What happens if I approve a loan that I shouldn't have?
I guess then if I approve one I shouldn't approve, there's a chance that that could be turned into a.
That's right.
Yeah.
So probably a 3 here too, right? That gives us a score of 9. And again, I think the diagram is very helpful in that you're able to look at essentially certain areas with a particular trust boundary, right? We already talked about the oracle. Yeah. Maria, Andrew, any ideas? All right. Then right. So likelihood of that. Yeah, I would make the case that it is 2 because it only impacts the pair where the token is a rug pull token as opposed to the entire protocol.
Sure, it's token specific, it's token bound, so.
Yeah.
all assets.
Right. Let's
Cetera.
et cetera, et cetera. And so again, like I think these prompts, like the stride prompts, basically what you should be doing here is look at spoofing, right? And then you basically look at the diagram here and basically ask the question, well, where could spoofing happen? And so it's really a systematic way to identify the risks of the protocol. And then once you're done with spoofing, you go to the next one, tampering, and kind of do the same thing. So you kind of go down the list.
So like. The ticket one or just as far as like an actual threat.
It's just kind of a prompt, and so then you I mean, you have to ask yourself a question in context of a DeFi protocol. So like kind of to manipulate functions on a contract probably would be super hard, right? But you could steal private keys and then you basically control these entities. And potentially, you know, even if there's like a library that calculates the interest that we said was upgradable through some other team, then if you're able to get the private key there, then you could update that, right? Or the Oracle, right? Yeah. Yeah, so you kind of use them as prompts. And you should go through them one by one. And then again, this is a little bit more specific around, I mean, it kind of categorizes it into market attacks, economic attack, off-chain, on-chain, and solidity. I'm not a huge fan of the categorization, but it's a long list of possible attack scenarios. And again, then you see somewhere here, price-induced Oracle vulnerability, right?
Or like, part of the idea here is the assumed breachment.
So again, we have now the likelihood and impact. We essentially order that, right? And focus on the top ones because everybody is busy and you never go the list. So the threat one is price speed manipulation. Any thoughts on how you would mitigate that?
Get multiple sources.
At 2, the entrancy. The entrancy card. Else can you? I don't know. Essentially, instead of sending the E to you, Andrew, basically, I say, okay, now those funds are unlocked, you can withdraw them. So then the transaction gets initiated by you as opposed to the contract initiating the transaction.
One it stands immediately, but like just a lock.
Yeah, it's essentially just, yeah, exactly. It's just, hey, I release them. And if you come to me, then you can withdraw them. but I wouldn't send it to you directly. And then this also could be a great candidate for monitoring, right? You can monitor reentrancy based on kind of the internal transactions as your contract called multiple times. So a variety of mitigations. Any, et cetera, right? Did that make sense in terms of the general process?
Got another of the flows described. And we're just doing one threat model document scoped to just that process.
That's right.
Don't worry about contract creation, all the other things that.
That's right. And so the flow that I would ask you to threat model is for the liquidation flow. So liquidation happens when the collateral value falls below a particular threshold as a percentage of the borrowed assets. So assume your collateral is 100, a requirement is 110%. If you borrow 100K ETH, deposit 100 ETH that are 120K of value. If ETH drops below that, then the entire position gets liquidated, aka sold on the DEX. And the user then, of course, can keep the borrowed assets because that's no longer in the control of the protocol. But in this particular example, the user would essentially lose 10K because the price of the ETH that got sold is still higher than the entire collateral that he holds. So yeah, create a Word document, similar fashion that we went over. If you look on in the file section, there is that document, which is essentially a template that you can use.
That like for the assets, the entry points, the adjustments, they are all the same that we use in this class, and so we need to create diagram and check model for that diagram. Just mitigation.
I agree. I think there's probably very little at the top in terms of the assets and the entry points that I can think of. Although I think we did not define the DEX. Maybe did we in the Fed model? So obviously, yeah. Let's look at the. No, you actually said the DEX, right? You identified that. So yeah. So I think yeah, those probably will not change. Could change. I mean, feel free to modify them. But you're right, Duke. It's primarily the diagram, the threats, and then the mitigations. Don't worry about it. I think it's more about the diagram. I think the most important step here is really looking at the threat categories and asking the question against the components that you identified in the diagram. And this list could be very, very long. I mean, I would guesstimate that you should at least identify 10 risks for the liquidation scenario. All right, look at that. It's 1 minute to 8. I hope this was fun. A little different than just me standing here and preaching.